Did we get through measuring distance? Okay.
No.
Okay, so this is where we'll start then. Measuring distance, obviously, our first lab had to do with measuring distance, right? We measured how far away from the target the Beanie Babies were. The SI units for length or distance are meters, and distance is simply the length of a path between 2 points, okay? Distance is the easy part. Displacement, though, is a little bit more interesting. So we're going to spend a little time, I'm going to draw a picture, and we're going to spend a little time talking about the difference between distance and displacement, okay? All right, so pretend you are in Whoville. Okay, and you've got city blocks that look like this. And you know how city blocks have buildings and whatnot on them. This is the quietest you've ever been. I'm going to remember that. Just record you every time. Okay, Walgreens is down here. Okay, and HEB is up here. Okay, so I went to HEB to pick up my prescriptions, and they said, we don't have your prescriptions. So I called my doctor, and she said, oh, I accidentally called them into Walgreens instead. Hypothetically. She actually did that yesterday, but then she changed it. Okay, but we're going to pretend that she didn't change it. Okay, so I'm up here at HEB, and Walgreens is way down here. Okay, if you are telling somebody how long it'll take them to get somewhere or how far it is, you generally don't tell them as the crow flies. Who can tell me what as the crow flies means, George?
It means if you start at one point and went directly in the same direction in a straight line to your next point.
Okay, so as the crow flies, HEB to Walgreens. As the crow flies from the front door of HEB to the front door of Walgreens is 31.5 inches on the map. So as the crow flies, this is how far it is to Walgreens. But when you tell somebody how far it is to Walgreens, do you tell them as the crow flies, or do you tell them as the odometer in their car would tell them?
As the odometer would.
That's right. So there are lots of routes to Walgreens, right? But I'm going to pick the most direct. So it is down this way and across this way, okay? So this is 31.5, right? And this is 22. And this is 20. Okay, so you would tell them how far it is. You would say it's 32 inches. Yes?
Wait.
Oh, 42. Okay, so as the crow flies, I'm just going to write it like that for now. It's 31.5 inches from HEB to Walgreens, okay? But the distance is 22 plus 20 equals 42 inches, right? Okay, so the length of the path, the whole path that you took, is the distance. Now displacement is different. Notice that it says straight line distance, okay? So displacement is the straight line distance, that would be as the crow flies, between HEB and Walgreens, which is 31.5 inches. Now, notice that it also says combined with the direction of motion. So a vector is a value in science that combines both distance and direction, or speed and direction, something with some measurement with direction, okay? You don't need to memorize the word vector, but you will come across it again in your other science classes and in math. In your book, there's a whole lot of stuff, yeah?
What is the definition of English for?
In your book, there are a whole lot of discussions of vectors and vector addition and things like that.
I'm just writing the comments.
Okay. However, I am not going to expect you to know how to add vectors. Okay, that's something you'll get to in your algebra classes eventually, and I'll leave that to your math teachers. All I need you to know is that displacement is one of those values that combines a measurement with direction. So in this case, to get to Walgreens, the displacement, so my displacement if I go from HEB to Walgreens is 31.5 inches southwest, because I'm going that way, right? Does that make sense? Okay, the times we need to understand displacement are going to be when we talk about rocks and how they were displaced from their original position by things like earthquakes. We'll also talk about displacement when we get into astronomy and talk about where celestial bodies are relative to us. So again, your frame of reference is part of displacement. Okay?